Welcome to Highfinder Expo Highlights. Today I'm joined by Mike Shanahan from Henkel, representing Loctite. What innovations are you guys presenting at the show this year?
Thanks, Stephen. Yeah, today we're representing our Loctite branded hydrogen-ready thread sealing solutions.
Okay, so these are thread sealings just for hydrogen?
Correct. They could be used for other gases, but the reason why we call them hydrogen-ready is because we've done testing in our own labs, plus as well as at Kiwa for certification against hydrogen on threaded fittings to demonstrate that we can withstand the pressures of hydrogen.
All right, okay. Why should customers care about that?
Well, one of the biggest challenges for the industry is leakage, especially from a safety standpoint, but also from an efficiency and a reliability standpoint. So it's important for our customers to have a reliable solution they can trust on their components and assemblies, and the Loctite thread sealing solutions provide that.
Okay, so it's great that you even brought some of it with you here.
Yes.
So which one is the one that we're actually talking about today?
So the most common we sell in the North America market is 567.
All right.
The reason why I have 577, knowing we are speaking to a global market, is 577 is more prevalent in Europe.
All right.
But 567 is what we're featuring at the show today.
Okay, so I need to ask you this, Mike.
Sure.
What is, I know there's like 10 counts different, but what else is different between the two? Is just different sizes?
I'm a marketing guy, not a technical guy, but yes, as far as the differences, 567 is more suited for MPT style fittings, which you'd find in the US predominantly. 577 is formulated particularly for BSPT style fittings. It will work on MPT as well, but the BSPT tends to have a little bit larger gaps in larger threaded fittings, so the 577 is more suited for that. This is more ideally suited for MPT, which we find more in the North American market.
All right, okay. So up to what pressures would this go?
The 567 we've tested up to 750 bar with no leaks.
750 bar, okay. So yeah, we were having a discussion earlier about bar, PSI. That's we'll work that out in bar, in PSI later on. But yeah, so how does it actually work?
Well, the way these work, these are anaerobic curing materials. So that means anaerobic without oxygen.
Yes.
So when you have a threaded fitting, the resin fills in the cross roots of the fitting. Okay. You take the oxygen out, you have metal there, that catalyzes the cure, and the material cures into a thermoset cross-linked plastic, so it's really inert. Okay. So it withstands and seals hydrogen.
So you mean like a sealing like this?
Correct. Correct.
Okay. All right. Okay. So does it work? You want to try this out?
Yeah. Well, I just want to demonstrate that. Also, one of the benefits is that it has very quick sealing properties. So I'm going to have a little demo here for us today. So I have a demonstration here. We'll apply some of the 567 onto the thread roots. Just a little material there. We'll take the fitting.
Just screw it in, basically.
Screw it in.
You don't have to.
The threads will spread the material throughout the diameter of the fitting. You can see I'm just getting it hand tight. Right? So now I have a little CO2 cartridge here.
What's that? Can I have a look at that?
Sure.
Like a CO2 cartridge.
CO2 cartridge you buy in a kitchen store.
Okay, right. And then you can put that in there. And you connect that there.
Connect that there.
Okay. And
thread it in. And you'll see once I start to break that seal in the canister, it's going up to almost, what did you say, 500 psi. Right there.
Okay.
Right?
So this is now pressurized this line here.
Correct.
We're at 500 psi. That's about 34, 35 bar, I think, something like
Correct.
that. Okay, and then
and that's instant.
That's instant.
That's instant. So it's sealing. It's sealing, right? And the nice thing about this material, unlike other like Teflon tapes, you can adjust the pipe to get it in position,
even though it's under
pressure. And it won't
leak,
even though it's under pressure, and you can torque it back down. If we did that with PTFE tape, you'd have it shredded material in there, and you'd have an unreliable seal.
You can really turn this as it's pressurized.
As it's pressurized. Yeah, you don't want to turn it too much because it won't be safety. But as you can see, it's holding the pressure. Oh, there you go.
Now you let it off.
Made you jump a little there, huh?
Okay, so there we saw there's pressure on that. Wow, this is fantastic. So that's the Loctite brand. Okay.
Correct.
So aside from being able to seal even while it's being twisted and turned, can you give us a bit of an outlook? How do you see this developing? I mean, like, would it seal even without touching, or what, how do you see this product line developing and spreading and helping the hydrogen economy?
Well, the way it helps is that, customers are using Loctite adhesive and sealants on a lot of their fittings today. So now they can be assured that it works with hydrogen because of our testing that we have on that. So that also allows them to use these materials in place of more expensive solutions, welding, cone and thread fittings that are more costly. They can use a traditional fitting with thread sealants.
All right.
So that's one of the advantages to our customers, and they're readily available.
Okay, so in total, this could be an even cheaper solution than welding it, or I think.
Much cheaper from a labor and cost standpoint, you know, and also it brings the reliability. So.
Okay, cool. Wow, okay, well that's a good outlook, because I mean, obviously in the hydrogen economy we depend a lot on scalability and costs coming down, and this is going to help. That's a great thing. Mike, thanks for dropping by.
You're welcome.
And sharing
My
these
pleasure.
insights. It's been an absolute pleasure. Hope you enjoyed it, and have a lovely day further.